I think eight more student. Okay, how are you today?
Okay, Doktor.
Fine, Doktor. Okay, Doktor.
Okay, baik. Okay, so while waiting, maybe you can update the attendance. And after this, I will call, I will ask you to turn on camera by section. Yeah. Share the attendance first. Okay, so please scan the QR code.
Doktor, saya tak boleh scan.
Siapa tu? Nanti saya panggil nama. Okay, we're waiting. Sekejap So while waiting, girls can prepare to turn on camera sekejap lagi. Just to make sure you are in front of your devices. Okay, another 17. If I'm not mistaken, some of you have class kan until 10. Lambat sikit dah tu. Fifteen. Okay. Is anyone is trying to scan the QR code? If not, I can just call your name manually. Another 13. Okay, 12. Okay. Ahmad Syawal. Ada. Aina Razita.
Saya, Doktor.
Okay. Alia Syafika.
Saya, Doktor.
Ada. Amirta. Divya.
Saya, Doktor.
Durgashini. Kawiyan.
Ada, Doktor.
Okay. Masturina Balkis. Nur Fatihah. Nurul Iza. Nurul Fatin. And Vimala.
Saya, Doktor.
Okay. So we have another 7. Still not update the attendance yet. Okay. Okay, currently we are 64. Okay, so I think another 5 is still not join us. Okay, no problem. Okay. So I need you turn on your camera by section because we can't see all of you in this screen. The maximum is 49 kan? Okay, so I would like to ask section 8 first. Okay, please turn on your camera. Section 8. Section 8. Okay, Mashita, Siti Zulalina, Ying, okay, Atira, Farah, Ika, mana lagi? Jin Heng, calling for section 8. Okay, how many of you from section 8 Section 8. Section 8, 15. Oh. 15 is updating the attendance. Suppose 18 students from section 8. Okay. And tunggu. Tak nampak semua lah. Sekejap. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lah. Baru 11. Mana lagi yang lain? 11, 12. Ni sebelah ke you all ni? Okay. Yes, I snap. Okay. 1, 2, 3. Mana yang terdapat lah ya. Let me share your group. Okay, ramai live meeting ni. Line tak okay ke? Okay. Thank you, section 8. Okay, section 4. Calling for section 4. Please turn on your camera. Section 4. Section 4. Calling for section 4. Okay, Kanisha, Adia, Nas, Abdul Rahman, Umi, Faris, Muhammad, Lukman. Dua Muhammad tu ada dua orang kat belakang tu. Satu grup ke? Satu section. Okay, Fatin. Nampak Muhammad je, tak nampak nama penuh. Semua Muhammad, ramai Muhammad ni. Ada empat Muhammad. 5. There are 5 Muhammad. Okay, Raviansha, Syarul. Ada lagi yang lain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Doktor.
Ya, Fatin.
Saya dengan Fatin tak sempat nak scan attendance.
Bella tak datang lah. Tak apa, nanti kita update. Awak dua orang ke pergi satu screen ni? Tak nampak.
Masturina dengan Din Adila.
Masuk sikit. Tak nampak orang sebelah. Okay, hold on. I'm taking snapshot first. Okay, then. Okay. So 1, 2, 3. Okay. So this is from section 4. Okay. Section 3. Call for section 3. Ziyi, Anas, Wayan. Ada lagi yang lain? Section 3. Okay, Shira, Tazmin, Muhammad, Anur, Divya, Adul Muhammad, Afiq. Afiq kat library okay. Mariam, line slow. Okay, Afika. Alia ada. Ada Alia. Okay. Ini je ke section 3? I think section 3 is fully occupied 30 student. Semua line slow Okay, so tak apa, kita snap. Dah buka. Okay, Rahana dah buka tapi tak nampak. Tak nampak muka Okay. So snap. 1, 2, 3. Mana yang dapat dah ya? Mana yang termasuk ni? Saya pun tak nampak siapa. Okay. Okay. Line slow bersabarlah. Line slow. Okay. So who still not update the attendance tadi? Sekejap saya check. I think there are another 5 kan tadi. Syawal ada tak? Abang Syawal. Amirta? Durga Shini? Masturina? Durga ada Okay. Masturina?
Saya doktor.
Okay. Fatiha? Nurul Izzah?
Saya doktor.
And Nurul Fatim tadi Okay. So we have left another three students still not update the attendance yet. Okay. Okay, actually for this week, we are going to look on the estimation topics. Okay, before we start, I would like to share the video on the estimation and confidence intervals. Okay, hopefully you can a brief explanation about the estimation and CI, confidence interval. Okay, what it's all about. Okay, let me share the screen first. Okay, so we are going to look on the estimates and confidence intervals topic for today.
Explains the concept of confidence interval and how to construct a 95% and 99% confidence interval with the help of some examples. So don't go anywhere else, just sit back, relax and enjoy this video. So before we understand what is confidence interval, let us first understand what do you mean by estimate. Everyone makes some kind of estimate at some point of time. Suppose you are crossing a road. You estimate the speed of a car that is approaching you. So based on this estimate, you decide whether to wait, walk or run. And everyone is making estimate. Managers, statisticians, they make a lot of estimate about the population. Let us look at the definition of estimate in the statistical term. Estimate is a specific observed value or a numerical value, I would say, which is used to estimate an unknown population parameter. It gives you some facts about how the population could be. We can have two different types of estimate: point estimate and interval estimate. Let us first look at the point estimate. So point estimate is a single value or a number that is used to estimate a population parameter. Let's take an example here. Let's assume that this is our population and we draw a sample out of it using any sampling technique. So we pick 4 people from this lot and we take an average weight of these 4 samples, which is coming around as 60 kg. So this 60 kg, which is the sample mean, is a single point estimate of a population mean. Point estimate is often insufficient because it is either wrong or right. Assuming that we know that we are wrong here and assuming that we are off target by 5 kg, so that means whatever we have expected 60 kg as an estimate is a good estimate here. But if you are off target by 20 or 30 kg, then that is not the right estimate. Also, this point estimate is going to be different from population parameter due to some sampling error. And there is no way we can know how close we are to the actual parameter. For this reason, statisticians prefer interval estimate, which gives them some range of values to estimate the parameter. That is why when we say point estimate, so sample mean is a point estimate of the population mean. Now let us understand the interval estimate. So interval estimate is a range of values which is used to estimate an unknown population parameter. It gives you the estimate that what is the range of values by calculating 2 numbers and interval but within which the parameter is expected to lie. Interval estimates of a population parameter are called confidence interval. And statisticians prefer interval estimate because interval estimates are accompanied by the statement concerning the degree of confidence. That is, the interval contains the population parameter being estimated. Confidence interval, which is the most common type of interval estimate, is made up of 2 elements. One is your point estimate and another is your margin of error. As it is written as point estimate plus minus your margin of error. So it indicates an error in 2 ways. One by the extent of its range and other by the probability of the true population parameter that is lying within this range. So this is how we define the point estimate and the width of confidence interval. Confidence intervals are often confusing. When we construct a confidence interval, we are estimating a population parameter based on the data that we have collected from a sample. So 95% confidence interval is a range of values that can be 95% certain or confident will contain the true mean of a population. So the correct representation of 95% confidence interval is that we are 95% confident that the population mean mu would lie between 50 and 70.
Siapa kata orang yang makan gaji tak boleh jadi jutawan? Hai, nama saya Alif Masli, seorang pelaku saham.
Now let us understand this with the help of some examples. So first example that we have taken, where we are constructing a confidence interval for a single population mean. So this is our problem statement, where we have a random sample of n equal to 50 males, which shows an average mean daily intake of dairy products equal to 756 grams with a standard deviation of 35 grams. So we need to find the 95% and 99% confidence interval for the population average. This is the formula that we have. We're going to use in this case. So we have given the sample mean as 756 grams, n equal to 50, standard deviation as 35, and for 95% confidence, z value is 1.96. That we can get it from z table. So let's put all this in the table for interval estimate. 756 plus minus 1.96 into 35 divided by 50. So we get, this is the range that we are getting for 95% confidence interval. Now for 99%, our z value is 2.576. Now we replace the z value with this and we get a different confidence interval. So now that our new confidence interval for 99 is this one, 743 plus 0.2 and 768.766 grams for 99% confidence interval. Now let's take a different case study where we are constructing a confidence interval for a single population proportion. This is our problem statement, a billing statement for 1,000 patients discharged from a particular hospitals were randomly selected for error. And out of these 1,000 billing statements, 102 were found to contain error. So we are using this formulation to construct a 99% confidence interval. So we are going to use this formula for population proportion. A P hat stands for X bar divided by N. A P is a random and varies from sample to sample, where N here is a sample size and X is the observed number of success in the sample. Let's put all this in the formula. So we have P hat as 102. That is the total error that we have divided by total number of patients. So we get 0.102. N is 1000 here. So we'll put this in the formula. We'll get this value. So this is our, and from Z table, like for 99% confidence, we get 2.576. I will put all this and we get an interval range as 0.077 to 0.127 for 99% confidence interval. So in short, we are saying that we are 99% confident that the true proportion of billing statement that contains error would lie between 7.7% and 12.7%. So that is all I have on this video. If you like it, click here to subscribe. 5% and 99% confidence interval.
Okay, so that's briefly explained about what is estimate and confidence interval. Okay, so let's look on the slide. Okay, the slide is I already upload in Author. Okay, hold on. Okay. So you can see this slide. Okay, on topic estimation. Okay, so we are going to look what is the basic concept of statistical estimation, and we are going to compute the point estimate of mu, okay, or mean, and construct the confidence interval where the interval containing the population parameter. Okay, so we have looked what is the estimation meaning. Okay, it defined by a process whereby we select a random sample from a population and use a sample statistic to estimate a population parameter. Okay, so there are two types of estimation, the point estimation and interval estimation. Okay, so the terminology on estimator. Okay, estimator is an estimator. Is a sample statistic from sample data that used to estimate the unknown population parameter. Okay, and estimate is a specific value of a sample statistic that assigned to the unknown population parameter. Okay, so this is the type of estimation. We have looked the example by point estimate and confidence interval. Okay, so if there are a point estimate, it gives you a specific value. Okay, a point estimate is a specific numerical value that used to estimate an unknown population parameter. Okay, different by confidence intervals. Okay, CI. later we are going to use abbreviation of confidence interval SCI. Okay, a specific interval estimate of a parameter that determined by using collected data from a sample with the specific confidence level of estimate. Okay, so this is the formula by properties of point estimators. Okay, the estimator should be an unbiased estimator. Okay, so we look the formula given. Okay, the estimator should be consistent and the estimator should be relatively efficient estimator. Okay, so this is the formula by unknown population parameter and point estimator. Okay, so if we look here, the point estimate by mu, okay, it's x bar equal to sum of x divided by n. Okay, and point estimate, we use the symbol x bar. Okay, and sigma or s, okay, s power of 2, okay, the standard deviation, right? Okay, equal to total of x minus by average x bar, okay, power of 2, and it divide by n minus 1. Okay, so we use this estimate by S2. Okay. Okay, sorry. This is a variant. S2 is variant. Okay, unbiased estimate for population mean and variance. Okay, from the population with unknown mu or mean. Okay, take a random sample of size n. Okay, so since estimator by x bar is mu, hence x bar equal to total of x divided by n. Okay, then we write mu hat equal to x bar. Okay, from a population with unknown variance, okay, sigma power 2, okay, take a random sample of size n. Okay, so it given the formula. Okay. So this is the unbiased estimate from a population where the population of success P is unknown. Take a random sample of size n. Okay, P hat equal to x divided by n. So there are so many formula. So we look on the example. Okay, for example, the mean annual salary for public school teacher is 32,000. Okay, annual salary. Okay, the mean salary for a sample of 750 public school teachers equals RM 31,895. Okay, identify the population. So you need to identify the population by given input of mean. Okay, the population mean and the sample mean. Okay, so identify the parameter and the point estimation of the parameter. Okay, so the solution, we have given input mean. Okay, mean is 32,000. Okay, and the mean salary for sample. This is a mean mu for the population and the sample is 31,895. Okay, so you need to identify the parameter and point estimation of the parameter. Okay, so the parameter is mu and a point estimate of the parameter mu is 31,895. It's very direct. Okay, so what is confidence level? Okay, the CI, confidence level. Okay, for the purpose of knowing how close the point estimate to the population means or variance, statisticians prefer to other type of estimate that is called an interval estimate. Okay, interval estimate is an interval or range of value that is used to estimate the true parameter. Okay, and the confidence level is the probability that the interval estimate will contain the true parameter. Okay, so we look on the example of estimating the speed of car when you want to cross the line, right? Okay, so we confident the estimate or interval estimate are true, that value. Okay, so a specific interval estimate of a parameter that determined by using collected data from a sample with the specific confidence level of estimate. Okay, if alpha is the probability that the estimate is in error, then 1 minus alpha is the probability that the estimate is correct. Okay, so what mean by the level of confidence? The level of confidence is the probability that the interval estimate contains the population parameter. Okay, so we can see here the level of confidence is the area, alpha is the area beneath the normal curve between the critical value. Okay, so we are going to look on the Z table, the value. Okay, so we are identify how many percent of level of confidence, okay, and the values between in Z score. Okay, so remaining area is a tail is 1 minus alpha. Okay, common level of confidence in statistic we are using common level of confidence is 90%. Okay, this means that we are 90% confident that the interval contains the population mean. Okay, so like you we see the example of identifying weight, okay, between the sample taken. Okay, so we, for example, we have a population 70% weight, okay, but we just only take only 4 sample. Okay, so we are going to estimate the weight, okay, and we can check either it is true or not. Okay, so we are confident, that's called level of confidence, 90%. Okay. So the corresponding of Z score plus minus 1.649. Okay, so we can refer Z table if the level of confidence 90% is 0.90. Okay. We look on the let me show you the Z table. Okay, so this we look on the example how to find the Z score using
Hello
Z
everyone, my name
table.
is Charles. In the past 6 years, I've managed to accumulate up to 5 million words.
In this video, we're going to focus on a quick and simple method of finding the z-score given the confidence level. Now, for those of you who want to commit this to memory, here are some common values. If you have a 90% confidence level, it corresponds to a z-value of 1.645. If you have a 95% confidence level, it corresponds to a z-value of 1.96. A 98% confidence level corresponds to a z-score of 2.33. And a 99% confidence level corresponds to a z-score of 2.575. Now let's talk about how we can get those numbers. So we said that a 95% confidence level corresponded to a z-score of 1.96. Let's talk about how we can get that. So first, we need to calculate the area under the curve to the left. And it's going to be 1 plus the confidence level divided by 2. The confidence level is 95%. If you divide it by 100, you're going to get 0.95 as a decimal. So this is 1.95 divided by 2, which works out to be 0.975. So let me give you a visual illustration of this. Let's say this is the mean, this is our positive z-score, and this is our negative z-score. Between negative z and positive z, the area of this region is going to be based on the confidence level, which is 95%. So this area is 0.95. The other 5% is covered by the area highlighted in blue. So it's divided into 2 parts. So 2.5% or 0.025 will be on the right, and 0.025 will be on the left. So if we wish to get the entire area from the left up to positive z, it's going to be 0.95 plus 0.025, which works out to be 0.975. So if you don't want to draw a picture, if you simply want to calculate that area, you could use this formula to do so. It's a quick and simple way to calculate the area under the curve to the left, and then you could use that to get the z.
Okay, this not showing how to read the Z table. Okay, let's look here. The Z table.
In this problem video, I'm going to show you how to find Z star or your empirical value for any confidence interval. It doesn't matter what it is. So in this case, I'm going to do 96%. So what you're going to do is I always draw the picture. Because we want a 96%, I put 0.96 in the middle. Now if you want a 99%, you put that in the middle, 95%, 97%, anything you want, you put that amount in the middle. So 96% means put 0.96 in the middle. Then figure out how much is going to be in each tail. So if I do 1 minus 0.96, that's going to give me 0.04. But that's both tails combined. So if I take that and divide by 2, I get 0.02. So that would be in one tail. So I have 0.02 in this tail. I have 0.02 in this tail. And I'm looking for this Z star value that makes this dividing line right here. There are 2 ways you can do this. Either way, you're going to get the right answer. Okay. I can look up, because our table only gives us areas to the left. It doesn't give us areas in the middle. So I could look up what this line is, and it has 0.02 to the left. So if I go to my normal curve and look at 0.02, so a normal curve, I'm looking for an area that's in the inside of 0.02. The closest I'm going to get is this negative 2.05. Now, if you have a calculator, it'll be slightly more precise. If you went with this value, it's just going to be slightly different, not a big deal. So it looks like my Z value is negative 2.05. So this is negative 2.05. Now we always want a positive value, so we could come over here and say by symmetry, this Z star would now be positive 2.05. So if you look at 0.02, you get v equals negative 2.05. We could also look and say, well, what's this value? What's all the area to the left? That would be 0.98. So we can look up 0.98 on my table and see what z value we get. Scroll down until you get 0.98 in the middle, because again, that's where the areas are. Here's my closest. It looks like we're at z equals 2.05. So we get z equals 2.05. And again, we just, for confidence intervals, always go with a positive result.
Entrepreneurs, do you feel like a hamster?
Okay, that's the example how we read the Z table. Okay, so actually there are so many video. You can just find it. Okay, so this is the example. If the confidence level is 0.9 or 90%. Okay, 0.9. So the corresponding Z score plus minus 1.645. Okay, try to find it. Is it true, this number? Okay, 1.645. Okay, let me, I think I need to upload the Z table in Author. Yeah, hold on. Okay, for exercise, maybe you can check, is it a correct value in this slide? Okay, I already shared the Z table in Author. You may refer it. Okay, from the video, can you find, is it true, the value? If, okay. Okay, you may check either the level of confidence 90%, it will give you this value if you are referring in Z-score table. Please check. Do you remember how to read it? Okay, why this is 0.05? Can you get it? Why? Because 1 minus 0.90, okay, and divide by 2. So that's why in this area is 0.05 and this area is 0.05. Okay, so then you need to find the 0.5. Where is it? The 0.5. You need to find out which one is 0.05 from the table. Okay, and the closest value. So from there, you will get 1.649. Okay, so the area 0.9. Okay. Next, we can look on the example of if there are a level of confidence 95%. Okay, so please check. Is it true this value? 0.95% is 95% confidence level. Okay, so we are going to find out what is the interval value between this score, okay, using z-score. Okay, and from the z-score, it gives you 1.69, okay, here. So you may refer
For a long time. Underline this.
to the very basic or simple example. Okay, let me share the link.
In this problem video, I'm going to show you how to find Z star for your critical value for any confidence interval. It doesn't matter what it is. So this
Error. Okay, so you may check either you get the same value or not. Okay, by this is the example. If we are going to have a confidence level 95%, so from the z-score, the interval value will be plus minus 1.69. Sorry, plus minus 1.96. Okay, and if the level of confidence 99%, okay, this means that we are 99% confident that the interval contain the population mean. Okay, so you may check with the Z table. It will give you the score from Z score plus minus 2.575. Okay, so this is the confidence interval for the mean in single population. Okay, if the formula it give you a variance input, okay, and unknown, okay, for any value of sample size. So you may do the calculation using this formula. Okay, so if the variance is unknown and sample size more than 30, so you are going to use this formula. Okay, and in case 3, if the variance are unknown and sample size less than 30, so you are going to use this formula, this given formula. Okay, for example, a study was carried out to estimate the average life of a large shipment of light bulbs. Okay, in previous study indicate that the standard deviation, okay, is known to be 100 hours. A random sample of 50 light bulbs was selected and indicate that the sample average life was 350 hours. So you are going to construct a 95% confidence interval estimate of the true average life for light bulb in this shipment. Okay, so you are identifying the input given. So we can see here it give you a standard deviation 100 hours. Okay, standard deviation. And the sample is 50. Okay, so the total or the sample average life is 350. Okay, so you are going to find out the confidence interval for 95%. Okay, so 95% equal to 1 minus alpha 100%. Okay, so the alpha is 0.05. Okay, so you are going to determine the case. From this case, you are given the standard deviation input. So automatically you can have the variance input, right? Okay, so you are going to use this case 1 formula. Okay, replace it in the formula, the input given. Okay, so find out this is the interval, confidence interval of 95%. Okay, confident that the average life of light bulb is between 322.28 and 377.72 hours. Okay, so we are going to estimate. We want to know what the value of estimate interval estimation here. Okay, from the given input. Okay, so how about this? A random sample of 35 television picture tubes was selected and the specified brightness was evaluated for each tube by measuring the amount of current required. Okay, the sample mean of current required is 280.3 microamps and the sample standard deviation is 10.3 microamps. Construct a 90% confidence intervals on the mean current required. Okay, so it also use the case 1 because it give you the variance value. Okay, for any value of sample size. Okay, so just replace it in the formula. Okay, so if the case 2, the variance are known, but it gave you a large sample size, more than 30. So you're going to use this formula. And the case 3 is if the variant are unknown, okay, but it give you the input of small sample size mean less than 30. Okay, so you're going to use this formula. Okay, so suppose that the random sample of an observation is taken from a population in which proportion of success. Okay, remember the proportion of success is P. Okay, and another one is failure. Okay, 1 minus P, right? Okay, when the sample is large and more than 30, an approximate 1 minus alpha 100% times 100% confidence interval for population proportion P is given by this formula. Okay. So this is if you have a proportion population. Okay, for example, it gives you this case study. Okay, and importer orders a large assignment of potatoes. When it arrived, he examined a random sample of 50 boxes of potatoes and find that 13 boxes contain at least 2 bad potatoes. Okay, find an approximate 98% CI, confidence interval, okay, for the proportion of box containing at least 2 bad potatoes. Okay, for the for the solution from the formula, we have now the proportion 13 out of 50. So it give you 0.26. Okay, and the approximate 98% of CI, PS plus minus Z. Okay, so you are replacing the value. Okay, so if you can see here, this is the proportion value 0.26. Okay, if you can remember how you get this value 2.326 from where? From where this value 2.326? Anyone want to try? Okay, so this is the value of 98% of confidence level, 2.326. Okay, so you're going to replace it. Okay, how about this one? 0.74 from where? Anyone want to try? From where you get this value? 0.74.
Value of failure.
Yes, value of failure. Correct. Mean 1 minus 0.26. Okay, so it give you the failure value. Okay, so you are replacing that value and get the answer. The approximate confidence interval is between 0.116 and 0.404. Okay. So this is the confidence interval for the two population proportion. Okay, there are so many formula. Okay, so it depends on the case study given. Okay, so this is if you are given the two population proportion. Okay, by this example, it just only give you one proportion population case study. Okay, so there are actually so many more exercises in this topic after this. Okay, for now, any question on the estimation?
Saya rasa doktor salah masukkan nota untuk estimation kot.
Oh, ya ke? Tajuk apa tu?
Sampling apa distribution yang minggu lepas punya.
Oh, tapi tajuk estimation
Oh,
okay, jap saya replace. Salah tajuk, salah save code. Okay, I also just received a project question ni nanti saya share sekejap lagi. We may take 5 break. Yeah. We are going to start another 5 minutes. Cukup 5 minit. Ke 11.15. 11.15 kita start.
okay doktor.
Okay. Okay, sorry ya. Okay, I already upload the question of project. Let me check the. Okay, you may check. Oh, okay. Belum appear Hold on. Okay, you may check the group project in your author. Okay. So it remain with the same team member. So if you are willing or want to request to change your team member, you may ask me. Okay, so I can open the log. Okay, so you can see my screen.
Yes.
Okay, so I just received this question, so we can read together. For statistic project, okay, the group project consists of 4 or 5 members. Okay, and select your own group member within the same section. It's never mind, maybe some of you are from different section, right? But still in same author. Okay, in same lecturer. Okay, so this project will constitute 15% towards of total mark. So I hope that everyone are focused to complete this project. Okay, because 15%, right? Okay, you know, the midterm is 20%. So the project is 15%. And I'm planning to give you a quiz of 5% next week online. Okay, just objective. So you are going to answer the quiz next week, during the class on Wednesday online. Okay. So the content of the report, you are required to list down all these requirement. So in cover page, we list of group members. So make sure you are write all your team members name, okay, metric number, and from which section, and lecturer name. Okay, don't forget which one is your lecturer. Okay, for project in section 8, you have 2 lecturer, right? I'm as in kuliah class and Dr. Raja in lab. Okay, so you may write down my name because I will mark your project report ni. Okay, so you need to refer on evaluation rubric in appendix A and peer evaluation form for each group member. They are in appendix B, and group time sheet, okay, appendix C. Okay, on the problem solution, you are required to select one set of question and set of question number must follow group number you write in author. Okay, if in author you are group number 5, then you must choose set number 5. Okay, so in our group, okay, for group 1, we don't have team member, so I can remove. Okay, so it start with group 2. Anyone want to request change team member or what? Okay, so we have 19 group. Okay, so it will be followed the question with the group number. Okay, for example, let we look here. Where is it? Okay, for example, if you are in group 2, okay, group 2. So that there are how many set? Set 1, set 2, set 3, set 4, set 5, 6, 7. Okay, there are 7 sets. Okay. There are 7 sets. Set 1, set 2, set 3, set 4, set 5, set 7, sorry, set 6, set 7. Okay, so it will be group 1, group 2, group 1 we don't have a team member. 3, 4, 5, 6, 7, okay, group 8, group 9, group 10, group 11, group 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so check. Of machine. Okay. So please take note. Please check you are from which group, and you are required to answer the question followed by group number. Okay. Okay. What else? Here. Hold on. So what else? Okay. And then format for the project report, font size 11 times enrollment and spacing 1.15. So each group must prepare video presentation of the project, the video duration between 10 to 15 minutes. So please make sure all members of the group must involve in the presentation. Okay, so you are required to record your presentation, okay, and submit in order. Okay, report and video presentation submission deadline will be 2nd July. Okay, your report must be in PDF format. Please submit your group project report hard copy and through author, and video presentation via author. Okay. So okay, so this is the rubric, report assessment rubric. You are required to beside to answering all the question. So this is what I will assess from your reports and presentation here. Okay, so you may refer this rubric. And also you are required to rate yourself and your team members. Okay, so you need to list down your team member and give the rating for them. Okay. So if you are in there are 3 students in one team, so there are 3 sheets. There are 3 sheets will be submit to me. Okay. So group time sheet. So you are required to detail who are present. For example, we are looking on the set 7. So there are four questions. So you can detail who are taking part question 1, who are doing question 2, and so on. Okay. That the time sheet. So this one you also required to submit with your report. Okay. Okay tak? Any question for the project? It's around one month lah. You need to complete it. Okay tak?
Okay, Doktor.
Okay. So you may start to do to discuss with your teammates and distribute the question. Okay, I don't want at the end of deadline tu ada lagi yang bagi tahu kawan tak buat apa semua kan. So it just you need to detail in time sheet tadi tu. Okay, so for the project will be 15%. Besar tu. Banyak. Bukannya sikit. Okay. And don't forget the midterm will be, midterm pula. Quiz will be via online in next week session. Okay, Wednesday. So in class session tu between 10 to 12 Wednesday. So the question will be pop up in author. So make sure you are answering in author. Okay, and the attendance also counted by when you are submit your quizzes lah. Okay, and next week also Monday will be public holiday. Okay, so for lab section 3 also will be run online. I will upload the question lab 10 lah. Okay, for section 3 and section 4 you may access the question for lab 10. So you are required to complete it and submit in author also. Okay, so the attendance will be counted when you are submitting your exercises. Okay, understand? Boleh?
Boleh, Doktor.
Boleh. Syawal tadi tak update attendance lagi Siapa lagi yang tadi ada 3 orang lagi belum update.
Saya, Doktor.
Sekejap saya buka balik. Okay. Chawan ada Amita.
Ada je.
Amita. And Fatihah.
Saya Doktor.
Amita tak ada Mana Amita? Ada sesiapa nampak Amita tak?
Line dia slow kot. Tapi dia dalam mic.
Ada Mana Amita nampak? Nampak Amita tak? Itulah kadang apa? Ada Amita. Your line in college code slow. Okay. I also want to share with you the p-test and square test. Okay, in last week topic, suppose in last week topic for sampling. Let's look together. Tengok yang pendek sikit video. Okay, this is for the last week topic in sampling. Hari ni kita estimate kan.
Learning statistics does not need.
Cari video yang menarik sikit. Ada banyak value test apa semua.
Difficult. Now, instead of bombarding you with complicated formulae and statistical theory, I'm going to walk you through a way of thinking, and that's going to enable you to address the most common statistical questions. When we look at sample data, for the most part, we see two things. We see differences between groups, so men are taller than women, and we see relationships between variables like taller people way more than shorter people. And the big question is, are those differences and are those associations or relationships real? And I'm going to talk you through what it is that we mean by the term real. Over the next few minutes, we're going to take a look at a very simple data set. And we're going to see how, by looking at various combinations of variables and variable types, we can identify very specific differences between groups and very specific relationships between variables. And I'm going to walk you through when and how to use statistical tests and how to interpret your results. Now let's imagine that we have a research question and it's about the height and the weight of people living in Ireland. Of course, we can't measure the height and the weight of the entire population. So instead, we take a random sample of the population and we measure the weight and the height of that sample. And we collect some additional information like gender and age group from each of the people in our sample. And we arrange these data in a spreadsheet or a data set with the various attributes in columns. And these are called variables. And these variables will be the object of our inquiry. Now, most data sets that you work with will contain two types of variables, categorical and numeric variables. Categorical variables, like gender, contain categories, as the name suggests. Think of them as groups or buckets that the data can be arranged into, in this case, males and females. Numeric variables, like height, are numbers, as the name suggests, and can be arranged on a number line.
to understand our data and to make sense of it, we summarize it and we visualize it. In the case of categorical data, we can count up the number of observations in any given category and we can represent them in a table and on a bar chart. And to summarize numeric data, we're firstly interested in the spread or the distribution of the data. So we might describe the range of the data, the interquartile range. We could also include the standard deviation. To get a sense of the middle of the data, we use the median, which divides the data into two equal halves, and we use the mean, which is the average. The mean is probably the most commonly used summary value to represent this kind of data. We can visualize our data using a box plot, which is a visual representation of the range, the interquartile range, and the median. And of course, we can create a histogram, and this gives us the shape of the data. So I hope you can see that this process of summarizing and visualizing the data takes it from being just numbers and words on a spreadsheet and turns it into something that is meaningful to us, something that we can get our heads around, something that we can think about. Now, in this very simple data set, we've got 2 categorical and 2 numeric variables. And things start to get interesting when we start looking at combinations of variables. So, for example, we can take a look at a categorical and a numeric variable like gender and height. And so we can group the data by gender, which is the categorical variable, and create a summary of the numeric variable, in this case height, that is separated out into those 2 groups. And looking at the summary, we can see that in our sample data, men are on average taller than women. What I want you to see here is that we've looked at a combination of a categorical and a numeric variable. But as you can imagine, there are other possible combinations of variables that we could have looked at. We could have looked at height and weight, which are both numeric. We could have looked at gender and age group, both categorical. And in each case, we might see either differences between groups or relationships between variables. And in each of these cases, there are specific statistical tests that we can apply to see if what we are seeing in the sample data has implications for what we think about the wider population. Can we infer anything? Is what we are seeing statistically significant? So let's take a quick look at the 5 most important combinations of data that we have. And we'll look at firstly, what might we observe in our sample data given that sort of combination of data types? And secondly, what statistical tests we might apply to determine whether or not we can infer anything about the wider population. So we might look at a single categorical variable like gender, and we could do a 1 sample proportion test. For 2 categorical variables, we would do a chi-square test. For a single numeric variable, we'd do a t-test. If we have a categorical and a numeric variable, we do a t-test, or analysis of variance, or ANOVA, if there are more than 2 categories in our categorical variable. And for 2 numeric variables, we do a correlation test. Now, I'm going to come back to each of these scenarios and each of these tests, so don't panic. At this point, what I want you to see is how the data can be divided up. And in just a few minutes, we're going to take each of these scenarios and work through exactly what questions you can ask and how it is that you can apply statistical tests, and importantly, how to interpret your results.
Adakah anda simpan duit dalam fixed deposit kerana yield berisiko rendah dan kadar fund?
Now, before we carry on, I just want to say a big thank you to Biomed Central, or BMC, for sponsoring this video. BMC are a publishing company that publish open access journals, and that means that the full team honestly believe that they are making the world data set and just randomly stab around blindly hoping to find something that's statistically significant. Before you interrogate the data, you start off by defining your question, your hypothesis. You define your null hypothesis. You identify the alpha value that you're going to use, and then you analyze the data. So let's look at what we can do with just 1 categorical variable like gender. We might ask the question, is there a difference in the number of men and women in the population? Now, we could state that as a hypothesis, which is that there is a difference between the number of men and women in the population. And we could check to see whether or not we think that that is the case. And when we look at our sample data, well, we do in fact see that there's a difference in the proportion of men and women. So should we get excited? Well, no, not yet. Remember, this is just sample data. We could have, by chance, selected a sample that just happened to show a difference. So let's consider the possibility that in actual fact, there is no difference in the number of men and women in the population. And we call that our null hypothesis. And if that were true, how likely would it be? What are the chances? What is the probability that we would see the difference that we have observed, or a greater difference for that matter? And if we can show that that probability is low, then we can have a degree of confidence that the null hypothesis is wrong and we can reject it. But before we calculate this probability, which we're going to call our p-value, we must be clear about how small is small enough. Below what value of p would we reject the null? And we must decide on that cutoff before we calculate the p-value. And we call that cutoff the alpha value. And for the rest of the examples in this video, we're going to use an alpha value of 0.05. difference, which is that there is a difference. And the next step is to apply a statistical test. In this case, we do one sample proportion test, and we generate a p-value. If the p is less than the alpha, then we can reject the null hypothesis and state that the difference that we observe is statistically significant. If we add another categorical variable, in this case, age group, we may have a research question like, does the proportion of males and females differ across these groups? So our hypothesis is that the number of men and women that we observe is dependent on the age category that we look at. In other words, the proportions change or depend on or are dependent on the age category. Now we can collect our sample data, we look at it, and we can see that, yes, in fact, the proportions do change across the age groups. In other words, in our sample data, the proportions are dependent on age category. Now, is that due to chance? Well, let's test the idea that the proportions are all the same, or that they are independent of age category. That's our null hypothesis. Now here we can conduct a chi-square test, and that gives us a p-value. And if the p-value is less than the alpha, we can reject the null hypothesis and state that our observation is statistically significant. If we want to look at just one numeric variable on its own, like height, then we don't have any groups to look for differences between, and we don't have another numeric variable to look for some sort of association or relationship with. So what questions can we ask? Well, we might have some theoretical value that we want to compare our data to. For example, in the case of average height, we might have some historic data. We might wonder if the current population is significantly different from that historic data. So our question might be, is the average height different from a previously established height? Let's imagine that the previously established height was 1.4 meters. We want to know if the average height in our current population is different to that. Our hypothesis is that there is a difference. Again, we collect some sample data, we find that the average height is indeed different from the historic height. Is that statistically significant? Well, if there were no difference, what would the chances be that we observe the difference that we do, or a greater difference? We conduct a t-test, comparing the averages, and if the p-value is less than the alpha, then we can reject the null hypothesis and state that the observed difference is statistically significant. Now let's consider a categoric and a numeric variable. And we may ask the question, is there a difference between the average height of men and women in this case? Our hypothesis is that there is a difference. In our sample, we do observe a difference. Let's assume that there's no difference. We conduct a t-test, which gives us a p-value. If the p is less than the alpha, we reject the null, and we state that the observation is statistically significant. If we had a categorical variable with more than two categories, like age group that's got 3 categories, then instead of doing a t-test, we would do an analysis of variance, or ANOVA. Now let's look at the last combination of variable types in this data set, 2 numeric variables, height and weight. Here we might start with the question, is there a relationship between height and weight? Our hypothesis is that there is a relationship. We collect sample data, we look at it, and voila, we do see some sort of relationship. Is it real? Well, let's assume that it's not. Let's assume that there's no correlation between the 2 variables. And if it weren't real, then what are the chances that we'd see the relationship that we do? And here we conduct a correlation test. Now, a correlation test is going to give us 2 things. Firstly, it's going to give you a correlation coefficient, which tells us something about the nature of the association between the 2 variables. And I'm going to talk about that in just a minute. But of course, it also gives us a p-value. And again, if the p-value is less than the alpha, we can reject the null hypothesis and state that the correlation that we see is statistically significant. And the correlation that we see can be represented by a number that we call the correlation coefficient. So let's talk about that for a second. Correlation coefficient is a number between -1 and 1. And it looks at the relationship between 2 numeric variables. If, as the x variable gets larger, the y variable gets smaller, we say that they are negatively correlated. If they are perfectly negatively correlated, then the correlation coefficient will be -1. If there's no relationship between the 2 variables, then the correlation coefficient will be 0. And if there's a perfectly positive correlation, as x goes up, y goes up, then the correlation coefficient will be 1. And of course, you can have any value in between. And by the way, it doesn't matter which of your variables is on the x and the y axis. The correlation coefficient will be the same. Now, of course, we've only just been able to scratch the surface in terms of what there is to learn about statistical analysis. If you want to learn more, then
Okay, so that's on the on surface lah. Okay, so actually from the same data, we can have a very more tested test. It depends on what the hypothesis and there are so many terms after this. Okay, so next topic we are going to look on the hypothesis. Okay, so any question for today? As for now, maybe on the topics and the project.
For now tak ada, Doktor.
For now tak ada. Okay, so if that's your question, remember next week our classes will be run via online. The lab, you just open the lab exercises and complete it and submit. Okay, the attendance will be counted by the submission. Okay, and also for the Wednesday, you are I hope that you are prepared for doing the online quizzes. Okay, I am planning just the objective question. Okay, so you may choose wisely which one is the correct answer. Okay, so the quiz will be carry 5%, quite large carry marks juga, proportion of marks. Okay, so if there's no question, I hope that we can see you again for next session. Thank you very much for your attention. See you. Okay.
Thank you, Doctor.
Okay, Umi.
Thank you, Doctor.
Okay,
Thank you, Doctor.
Doctor.
Thank you, Doctor.